Okay, testing. Hey, welcome to Programming Rainbow. In this video, we will continue on the series of Minesweeper in C and SDL3. This is the 13th video, so if you'd like to follow along with this one, you can go to github.com, Programming Rainbow, Minesweeper C SDL3. You can clone this repository, move inside the directory, open it up with whatever editor you would like, and I'll just show you the code. So I want to show the final product if anybody's just, coming in on this video. So if you are just coming in on this one, what you'll find in the source directory will be the final code. But since this is the 13th video, what you'll want to do is go down to the 12th video, copy this directory and rename it to SRC. So you can be following along with the code with where we are right now. But I do want to show you the final code. So you can compile the code from any of these directories by specifying the source directory. If you don't specify this at all, it'll automatically look at the SRC directory. So I'm going to do 16, the final code directory, and this is Minesweeper. Make it a little bigger, and it has different themes and stuff. Let me just show it to you real quick. I want to end it. So here's Minesweeper. We have different themes. You can see the kind of theme changing, and you can change the theme while you're playing. It doesn't affect the game. And these are the monochrome. These are also the Italian themes. These two themes right here, and this monochrome one these are all the Italian themes where they didn't call it Minesweeper. They called it like flower bed or something. I don't speak Italian, but it's something about flowers. And so over here we have the time, and over here we have how many mines we have. This is how many mines we have minus how many mines we've indicated. So if I go like this and I indicate that this could be a mine here, and so this is a different theme. Let's change it to a mine theme. There we go. We have a little bomb there. And you see this number's going down. That doesn't actually mean that this was a mine here. That just means I had 8 mines and I've indicated 4. So I should have 4 left. That's the correct way that this should happen here. And I'll show you if I end the game that these will be incorrect right here. And these are crossed out. So I incorrectly indicated. And the way that you win the game is by uncovering all non-mine squares. So it doesn't matter whatever you indicate on top of a mine square, these mine ones. If I've indicated it's a question mark or a mine, it does not matter. I do not need to turn over the mine. But every other square, I need to actually turn it over. So if I indicate a mine on any other square, and it's not a mine underneath, I'll never get to the win state because I need to turn that over. And I can't turn it over. I can't click on it. Oh, there's a bug. Well, we'll get to that later because this code doesn't necessarily match the code in this video, but it looks like clicking on question mark causing the mine number to go up, which is not right. Let's see. And clicking on mine. So we'll take a look at that later. I could have a bug, it looks like. So the way that you win this is by turning over all 9. And I got really lucky there because this is an easy setup. I have 8. So this is a mine. These 2 are mines, definitely. This is a mine. This is mine. This is not a mine. Could be a mine. It's not a mine. So this one over here is a mine. This is not a mine. This is not a mine. This is a mine. What do we got? We got 1, 2. So this is the problem. One of these 2 are mine, it looks like. And I don't know if this is a mine. I'm going to assume it's not. Okay, I got a little bit lucky there. So this one's definitely mine. And so because of this 2 right here, this has to be a mine. So this is not a mine. And I just won. And we get the sunglasses, how much time it took, and it's still saying mine because this is just how many mines are on the board versus how many I've indicated. That's all it is. So that's the game. And let's just show where we left off with in the last time, which I'm just going to do what's in the SRC directory now. And this is where we left off. I can't make it bigger, unfortunately, because we haven't changed the scaling. We haven't created that yet. So it's just at ×2 scale right now. But this game fully works, the time works, but we don't have this mine indicator. So everything else is working, right? The whole game works. We can win, we can lose, the time stops, everything else. But the indicator's not happening, so that's what we're going to do in this video. And hopefully the bug that we just saw earlier is not in the current code, but it could be, so we'll see if we can fix that too. Okay, so what I want to do is look at what is controlling the mines indicator are this mines C and mines H. This is just for the indicator. I called it mines because it's the mines indicator. So I do want to go into here, and just like what we did in the last video where we were doing with the clock, where we added this unsigned digits 3, I'm going to do the same thing here, but I don't need to keep track of seconds and last time. What I need to keep track of is how many mines I should have. And this number could go negative because again, it's how many mines I have versus how many I've indicated. So if I have 8 and I've indicated 9, it's going to say I have -1 mines. And that is correct. That's the way that it should work. So this is going to be an int that I'm using. So I can just grab this right here, this unsigned digits 3. It's going to be the exact same. This is 3 because we have 3 digits we're indicating. And then I actually want to keep track of like the mines that I'm trying to indicate. So it's going to be an int because it can go negative. And I'll say mine. I think I did mine count. Sorry, let me pull up my notes because I want to keep track with the, I did mine count. And yeah, those are the 2 that I need. So that'll kind of get us started there. Have an increment, decrement, and reset. So we are going to have some new functions in here. I guess I'll add them as we do them. So there will be 3 more down here, but I'll add them as I do them. I'm going to close this one right here. So this digits is going to be just the same that we did. Right now we're displaying a 0 for each one of the 3 digits. But since we have this array of 3 digits now, we can actually display what is there. And for right now, that's not going to be anything for right now because we haven't set up the function that does it. So I'm going to undo this. So let's create that function. It's going to be similar to the one in the clock where we use in the last video, we used ternary operators to set up, but in this one, we're not going to be using as many ternaries because it's a little bit more complicated logic because we can have negative numbers. And just pull up. So I'll show you what I mean real quick. In clock, when we set up this thing that actually decides based on the number what the 3 digits are, this is called the clock update digits. And we just used 2 ternaries and the bottom one. Unfortunately, the logic is going to be more complicated for mines because we can have negative numbers and stuff. So we can't do it as simple. It's going to be a little bit bigger, but it's the same idea. We are deciding based on this is seconds, and the other one will be mine count, what these 3 digits should be. So mine C, and I'm going to put it right up above here. So this would be void mines update digits. Okay. And the first thing I want to do is, again, this can be a negative number, but I don't want to deal with a negative number when I'm actually parsing out the digits. I just want a number. So I'm going to create a local variable, and I'm going to have mine count be the absolute value of mine count. I think is ABS return an int. Yeah. So I want an unsigned int. It's weird that it returns an int, I guess, because it's unsigned, like ABS should return unsigned, but I don't know. Maybe if it's an error, it returns -1 or something. I'm not sure. Not off the top of my head. So this is going to be mine count. So if this is a negative number, when I'm parsing, I don't want to deal with the fact that it's a negative number. I just want the number. And now, before we used a ternary to decide if it's over 999, we're just going to set it to 999. We did that in one go up here, but this one I need to know if it's over 999, I need to set it to 999. But if it's lower than negative, because I only have 3 digits, right? So my biggest number I can indicate is this, and the smallest number I can indicate is this, because negative is taking up one of the places. Okay, so that, because I have 3 digits to work with, negative is actually going to be one of those digits. So I'm going to just use the if statement here. If mine count is bigger than 999, we're going to make that local one, mine count, just equal 999. So it'll cap it. And then we're going to do the same thing on the kind of negative side. Mine count is smaller than -99. We'll just make the local one equal to -99. Okay, so that kind of makes sure that we're always within our scope to deal with what we want to deal with. Now, to get there can be 3 possibilities here for the largest, the hundreds place decimal. Okay, I could have something in the hundreds range. So say my number is like 457. Yeah, that's 4 is there. 4 is what I'm looking for. So if I were to divide this number by 100, and it's an integer division, I'm going to get 4, which is great. That's what I want. I want to get the 4 out of that 100 spot. That's one of the options. The other options is I could have something like 50, and I don't even want to divide that. I just want the placeholder. Okay, so I need that, which is 11. Let me show it. So this is 0 position in my source rex is going to be 0, 1, 2, 3, 4, all the way up to 9. This is the 10th one, which will be our negative, and the 11th one will be the placeholder. So if I have something, like 57 or 86, or who cares, I want it to be instead 11 on that hundreds place. And the other one is if I have a negative anything that's between -1 to -99, I want the digit to be the negative. So I have 3 possibilities of what my hundreds digit's going to be. The negative is always going to be indicated in the hundreds digit, even if it's like -1 or something. I'm just going to make it that way. Okay, so that's kind of the logic of what I'm going to do here. So like I said, if it is bigger than 99, I can go ahead and just divide it and get that with the integer division and get the hundreds place. So if mine count is, and now mine count is always going to be a positive number here. It doesn't matter. I could use mine count or the other one. For this one, it doesn't matter. Either way, if it's over 99, it's still going to be either way. So if it is, I'm going to do this one, and it's going to be digits, and I'm going into the 0 index, which is I'm going to use this my hundreds position. I'm going to say mine count divide 100, and we get our integer division of whatever that hundreds position is. The other option is if it is less than 0, I need a negative in this position. So this one, I'm not going to look at this local. I'm going to look at the original one because I need to know if it's less than 0. The local one will always be bigger than 0. So right up here, I made a mistake. Good thing that I just caught this. This needs to be a positive number. This should be an M up here. So yeah, so my local number here is always a positive number to just help me deal with the logic of the situation. So if it's bigger than 99, it's 99. If the real number is smaller than negative 99, the local one is 99. Not saying the number is now positive, but for me to deal with the digits, it's just easier. Okay, so what I'm going to do now, since that local number is always the positive, I'm going to use the real one, not the local one. And I want to know if it's smaller than 0. So if it's smaller than 0, I'm going to use the 10 position right here, which is the negative. Zero. And so this one is going to be just 10. Okay. Now, if it's anything else, that means it's not a negative number. It's a positive number, but there's nothing in the hundreds position. If there's nothing in the hundreds position, I'm going to just draw the default, which is the placeholder one right here. Which is 11. Okay, so that is my hundreds position right there. Now, I don't have to worry about negative or anything else for the other one, so I can actually just use the ternary that we used in the clock for the next position. Or you could use an if statement. It doesn't matter. It's whatever style that you like. So our tens position is going to be the 1 index. And this one is going to be if it's bigger than 9. So this one was if it's bigger than 99. We're in the hundreds position. This one is if it's bigger than 9. So if it's bigger than 9, we have something in the tens position. So if we're bigger than 9, this is the ternary. And what I want to do is I want to take this number and divide it by 10, and then get the modulus of 10, which is going to give me the 10 position number, not the hundreds or the 1 position number. It's going to give me the 10. So here's what's happening. Say I have 3, 4, 5. Yeah, I need 4. 4 is in the tens position, right? I don't know why it's up there. That's cool. Oh, it's because I'm still working on this line. So if I take if I divide it by, I take 3, 4, 5 and divide it by 10, I'm going to get in integer division, I'm going to get 3, 4, right? Now if I get the modulus of 10 here, that is going to give me the 4. Sorry, the modulus. Modulus of 10 equals 4. So I hope that makes sense. There's probably some elegant way to do this. I'm just doing it, grug brain, just the dumbest way possible. That just works. So yeah, for me to get the center one, I'm just going to divide it by 10 and then take modulus of 10. And that's going to isolate out that center digit. Line count, divide by 10. And then 10 here. And we did the same thing for the time. And now if it's, so this is like an if-else statement. So this is saying, if this is true, do this one here. But if this is not true, we're going to do the default 11. Okay. That means this will also be a placeholder spot, and it'll be this one. Now, we never have a placeholder spot in the ones position. It's either going to be 0 or a 1. So this one is very simple. We're just going to do modulus 10 on the number. So we didn't divide it by 10 first. So this time when we do modulus 10, we're getting the ones position. So digits, and this one is the 2 position, which is going to be our tens, or sorry, our, what is it, ones position? Our decimal, I don't know, the 0 to 9, whatever it's called. And we're going to do modulus 10. The modulus 10, so again, if we had 3, 4, 5, we do mod 10, we're going to get the 5. So that's going to give us the ones position. Okay, so this is our mine update. Okay, so I'm going to go ahead and call this from up here, right at the bottom of the new. And yeah, I'm going to call it from here. Initially, it's going to just be 0, and that's fine because we haven't set up an initial mines number. I just want to show something being done. So mines, we haven't forward declared this either. So let me grab this function name right here, or function signature. Bring it up here. Okay, so we will have an initial, basically it'll be 0 initially because we haven't set, we have this new variable called mines count, but we haven't set it to anything, so calloc's going to have it 0. So this is going to run its thing and we should have 0. So now we can go down here and use that digits. So remember, we have 3 digit slots from left to right. We have 0, 1, and 2 as our index. And guess what? We're going through our index of 0, 1, and 2 right here, and with our different positions. So we can just say this is M digits, and we just use the I index that is coming from up here. So it moves to the different spot. It's going to display what's in that location. So right now, like I said, when I run this, if it's working correctly, it's going to just say 0. And there we go. But we don't have 0, we have 8 mines. So here's the next thing that we're doing. So I need to change this new, and I need to add in the mines. Okay. So our mines is already an int. Our mine count is an int. So I'm going to pass in as well an int, even though this is always going to be a positive number when we pass it in, because the other type is an int. I'm just going to use that. So this is mine count right here. It's going to complain because I got to change the signature in the header. But down here, I'm going to link it up. Mine count equals mine count. Okay, so that's great. But we need to change the signature, and we need to go into game now and pass in the mine. So in H right here, we need to add this in. And then in game, where we call this function. And before I do anything, we don't need these things up here. I'm not sure why I can't remember why I did this, but these are in the header file. In the game H header file already has board H, clock H, face H. So these do not need to be here. They're just redundant. So this one does need to be here, this init SDL, because this is not in the header file as far as I know. Okay, so nothing's changed. I still have one error here, but that's because of this guy right here. He wants the mines being passed in, and we already have the mines set up here, mine count right here. So we're going to pass that in. Mine count, and now that should be, I just kind of want to check in the game header if mine count is an int or an unsigned. Okay, it is an int. Okay. So now when we run it, it should say 8 because this is set up to have 8 mines. And we have our 8. But we're not indicating anything yet. See, the number didn't change. So that will be the next thing. Let me just pull up my notes again. So we got a couple little functions, basically. We're going to have a reset so that when we reset the game, we can reset the mine count. We're also going to have an increment and a decrement to move the number to increment it and decrement it. And I'm going to put these right above the... Sorry, I'm in game. I want to be in mines. So in the mines file, I'm going to put these right above the draw function. Yeah. So I'm going to have a mines reset, a mines increment, and a mines decrement. And these are all going to be viewed externally, so they need to be in the header file. So I'm just going to create all the function signatures first. And this one I am going to be passing in the mines, because on our reset, we might actually be changing how many mines we have. Also, we need to, the internal number may have changed, but no, that would be coming from external. But on the reset, we may have changed the size of the game. So now we have 20 mines or something like that. So I'm going to be passing the mines in on a reset. So I'm just going to act like it's function signature first, because I'm going to copy that. Increment, and it is struct mines. That is correct. But yeah, increment. Yeah, that's correct. I was thinking const, but no, because we are editing it, or we're mutating it. So the decrement is going to look like this. Decrement struct mines as well. So I'm just going to yank these real quick, add them to the header, and then we can fill them out. Like I said, all three of these need to be seen from game. Game is going to call reset, and game will call increment and decrement. Okay, so the reset is going to be quite simple. We are just linking in whatever the mine count is, and then we're calling the mine update, update digits. The mine count is just going to equal this, what we've passed into it. And then we're just going to call the mines date digits. And that's it. And the other two are quite similar. We're doing this. We're doing this exact thing in each of those. The other one we're just going to increment or decrement. So it's going to be mine count plus plus on the increment, and then we're calling that same function. And the just decrement on the other one. Count. Okay, so that's going to give us our reset, our increment, and our decrement. I think I changed the game reset. I just want to check my notes again, because if I've changed anything, I want to make sure. Maybe I didn't. Okay. So we're going to go into game. I'm going to deal with the reset first. So down below here, we have this reset here. We are setting the face to default. We are resetting the clock, and then we will be resetting the mine. Reset, and this is going to be G mines, and this one is going to be G mine count. Yeah, there's nothing. Okay, there's nothing else in here. So that'll give us our reset number. Now the action on the what's incrementing and decrementing the mines, this happens on the mouse up. So here's our mouse down. Here's our mouse up right here. So inside of the playing is playing. Oh, okay. We need to, sorry. Basically, I need to get an indicator if I've changed the board to indicate that there is a, if I'm indicating there's a mine or not. So we need to go into board first. And I think I have another, sorry, let me go into the header. Yeah, so I'm going to go into board H first. And I need to indicate whether I've indicated that I've added, I'm marking that a spot may be a mine, or I'm removing that that mark that it may be a mine. So I'm going to use an int. I'm going to just use a +1 or a -1 or a 0 if nothing happened. So it's going to be int mine marked. So this is when I'm using this right here. Oh, not this one. Check this guy out. So whenever I use this is a marked mine. So whenever I've done this, I need to decrement the number. But whenever I remove this and go onto the question mark or back to here, when I've gone from here to here, because it rotates in a circle, when you right click it, if you're here, it goes to here. If you're here, it goes to here. If you're here, it goes back to here when you're right clicking. So when I'm going from here to here, it's a plus. When I'm going from here to here, it's a minus. Okay. So this is why I'm using an int. There's going to be a plus or minus, but it needs to happen I need to get that information from the board. So that's this marked here. And I think we're going to have a header file, or sorry, a function signature to get this information back out. So we have this is pressed. Above this is pressed, I'm going to put board mine marked. And this will be the const struct board b, because we're not changing anything, we're just returning a value. I'm just going to grab this signature here, and this is above board is pressed, so that's where it's going to live. So in board C, I'm going to look for that function right here. And this is just going to be returning that the mine marked that we just created. Did we create that in the header? Sorry. It is there, mine marked. Okay. Don't know why it's, excuse me. Not sure why it's not seeing this. This isn't right. I must have messed this up in the header file as well. Should be capital B. Okay, board mine marked. Just returning. Where are we at? Yeah, let's doing nothing else. It's just returning it. In my notes, it's here, but I think the LSP will fix, will not allow that. Oh, it does. Okay. Sometimes it reformats it. So we have this as return in the state, but we also need to be setting this, whether it's mine marked or not. And that's going to be in the mouse up. So when we're in the mouse up and we're dealing with the right here. So I was trying to be clever and I changed this to what my original code was. But the reason why it was this way is because I actually need to be more granular. So we're going to be changing this code right here. I thought I was being slick, but there was a reason why it was originally like that, because I was setting each state. So we're going to say if row column is equal to 9, I'm going to do the column plus plus. So it's going to end up being 10. And then after that, I'm going to, wait, this is front array. Yeah, front array. And I'm going to set the mine marked to, let's say -9. Oh, because whenever we mark a mine, we're actually subtracting a number. So it's going to be -1. Because we had an 8, now it's going to say 7, our left. And now on this else one, we want to be checking. I'm going to kind of reduce this down. If this is 10, right? This is 10, we're removing the mine mark, so now we need to add. So that we're still doing this plus plus, but we're going to say mine marked equals 1. And then we're going to have one more. So if it is 11, it's going to go back to 9. Front array, row, column equals 11. And there's nothing happening with this one. This is going from the question mark to the blank one that we can see here. So when we go from the question mark to the blank one, we're not changing anything. We're only changing when we go to the mine being marked and away from the mine being marked. This is going to be a -1 here and then a +1 here. Okay, so that should set that up. But I also want to just put it at the very top of this function here. I'm going to set it to 0. So whatever it was set before, it's going to be set to 0 now. And in here, if one of those specific things are set, then it's going to set it to -1 or 1. Okay, so now we have this on the right mouse button, click on specific situations we're setting it, otherwise it's 0. And we have a way to get this information back out again with that getter. Where is it? The mine, this one right here. This is a way for us to get that information out. So we're going to go into game. No more best views for you. Okay, so in game, let me just make sure I'm on the same page with my notes so I don't get off. This is also going to be on the mouse up. So right here where we were working before, if it's is playing, I'm going to put if board mine marked. So if this comes back as 1, I want to increment the mine. And this will be G mines. Board mine marked. So if it's -1, I want to decrement. I think that's it for that. Yeah. I called it mine. So in my original code, I called it mines marked, but that didn't really make sense because you're only marking one mine. So I removed the S. So you're going to need to have it mine marked. Okay, so let's try that and see if it's working and also see if that bug is still there. So we're indicating 8. So if I put a mine indicator, it goes down to 7. And if I change it to question mark, it goes back to 8. So I'll indicate here, indicate here. There we go, 0. And now we got -1. That's nice. I'm going to reset. That did reset. So now the bug was happening when I indicated. Now when I left click, it must have just been my old code because my new code is slightly different. It's not doing it. Let me do this one and then click on it, tap, tap, tap. It doesn't seem to be doing it. So it must have been something with my original code. Yeah, it seems to be functioning just fine. Okay, so I think that's kind of everything, but let's test kind of cases that could be outside of the, so I want to check the kind of extremes. So in mines, let's see here. I'm just going to add a line here that just kind of changes the mines number. So the most mines that we can indicate would be 999. So let's go 998. Okay. Oh, it's not going to go higher because, yeah. Hold on. Let me indicate. Let me say 1,000 is here, which we shouldn't be able to show, right? And I don't need to do a clean. I'm just going to do a release run. So we were supposed to have 1,000, but it's saying 999. Now, if I indicate 1, it should still say 999 because that would be 1,000 minus 1, which is 999. And that's correct. So when I indicate 2, now I'm going down to 8. So that does look correct. Okay. That reset to 8 when I reset it because this is only in the initial. Let's try the negative. I'm going to say negative, and this one I got to go lower than the maximum. So I'm going to say 98. I think that's right. We'll try it. Okay. So I'm going to indicate, yes, and indicate it again, and it didn't go over the number. It doesn't go to 100 or something like that. Okay, so yeah, I think that's all looks correct. I'm just going to remove this.